Hello everyone, let's look into this problem. An American high school mathematics examination from the 1960s contained the following question. If x raised to power x raised to power, so the question is x raised to the power x raised to the power x goes up to infinity equals to 2. So we have to calculate what is x. The intended solution entailed observing that the exponent of the bottom x is the same as the whole expression. So the intended solution is that it is based on the observation that this x has the power same, which is equals to 2. Okay, it goes up to infinity, so neglecting x that doesn't change anything. Okay, so we can write x square equals to 2. So from here we get x equals to root 2. However, one student noticed that if the problem had instead specified that, so one student noticed that if x raised to power x equals to 4. Okay, so again we can do the same procedure. X raised to the power equals to 4. From here we get again x equals to root 2. Okay, so here comes so this is a kind of potential paradox. Look what we get root 2 power root 2 power root 2 goes up to infinity. From here we get x equals it is equals to 2. Okay, and from here we get x it is equals to 4. So this can be how it is possible that it is equals to 2 values. Okay, so the wrong answer or the problem is writing this equation. Like if we write x square equals to x square plus 4 and we subtract x square from both sides, we get 0 equals to 4. But writing this is absurd. Okay, similarly here x raised to power x can never be equals to 4. Let's prove it. Let's calculate first. Root 2 power root 2 power root 2, it goes up to infinity. What is its actual value? Okay, so let's assume that root 2 power root 2 power root 2 power it goes up to infinity is equals to x. Okay, so we can write it as root 2 power x equals to x. Okay, so from here we can say that if we take natural log of x to both sides, we get x ln root 2 equals to ln x. Okay, now we can write first we can write this x as e to the power ln x ln root 2 equals to ln x. Now we have W Lambert function, which is like this. If we give input to its x e to the power x, it returns me x. Okay, so try to make the form like this, x raised to the power e to the power x. So let's divide e to the power ln x to both sides. We have ln root 2 equals to ln x e to the power minus ln x. Now multiply minus 1 to both sides. Ln root 2 equals to minus ln x e to the power minus ln x. Now let's see, we have the same form like here, something e to the power something. So here comes, we can take Lambert function to both sides. Minus ln root 2 equals to Lambert function of minus ln x e to the power minus ln x. Okay, so what we get for to the RHS, W of minus ln root 2 equals to, we have whenever we have something e to the power something, Lambert function on that is equals to something. Okay, so from here we get W minus ln x. Now let's calculate this. What is this? So let's look into this inside term minus ln root 2. We can write this as minus ln 2 power half. We can also write this as minus 1 by 2 ln 2. So this can be written as 1 by 2 ln. We can make this minus inside, so 1 by 2 ln 1 by 2. This can be written as ln 1 by 2 ln 1 by 2. So now this is in the perfect form. So W of ln 1 by 2 e to the power ln 1 by 2 equals to minus ln x. Okay, So now it is again in the form something e to the power something, so we get ln 1 by 2 equals to minus ln x. From here we get ln 1 by 2 equals to ln 1 by x. So from here we conclude that x equals to 2. Okay, so root 2 power root 2 power root 2 equals to 2. So now let's see why it cannot be written as 4. Okay, what is the problem? From where up to what value we can write x raised to y? So this tetration y. So what is the maximum value of y which is possible? Okay, y cannot be write 4. So let's calculate the maximum value of y which we can put. So same procedure again, we can write x power y equals to y. So divide both side by x raised to power y. So we have 1 of y upon x raised to power y equals to 1. Now we can write this as y x raised to power minus y. Okay, so now 1 equals to, we can write this as, let's see, x raised to power minus y, we can write it as e to the power ln x raised to power minus y. So this is e to the power minus y ln x. So write 1 equals to y e to the power minus y ln x. Okay, so now to make the same procedure, same format, something e to the power something, we have to multiply both side by minus ln x. So minus ln x equals to minus y ln x e to the power minus y ln x. So now we have the good input for the Lambert function. So taking both side the Lambert function, we have w of minus ln x equals to w of minus y ln x e to the power minus y ln x. Okay, so now this we can write as w of ln 1 by x equals to, this we can write as minus y ln x. Okay, so from here we can calculate y, w of ln 1 by x upon ln minus ln x, which we can write as ln 1 by x. So this is the value of y whenever the sequence converges. Okay, so let's see what is the graph of w function. W function has graph like this. This is the value of w naught x, and the minimum values and the value of x which we can put into it is, this value is minus 1 by e and minus 1. So the value of x which we can substitute in Lambert function is greater than 1 minus 1 by e. So in this we have ln 1 by x. So ln 1 by x should be greater than equals to minus 1 over e. Okay, so from here we can say that 1 over x is greater than equals to e to the power minus 1 over e. From here we can say that x should be less than e to the power 1 by e. So this is the maximum value of e which we can substitute in this infinite tetration. Okay, we cannot substitute anything, like if we substitute 10 it goes to infinity. So this value is approximately equals to 1.44 and root 2 is equals to 1.41, so which is less than 1.44. so we can substitute root 2, it converges to 2, which we have proved earlier. Okay, so now let's calculate what is the maximum value of y which we can get. Y we cannot put in this equation 4. Okay, so let's see that. So we have y equals to w of ln 1 over x upon ln 1 over x. So let's plug this value, maximum value of x. So y equals to w of ln 1 over e to the power 1 by e. Okay, so ln 1 over e to the power 1 by e. From here we get y equals to w of ln e to the power minus 1 over e. Okay, upon ln e to the power minus 1 over e. So from here we get y equals to minus e w, this simplifies to minus 1 over e which goes into numerator, so ln e to the power minus 1 over e. Okay, now let's calculate what is this. ln e to the power minus 1 over e is equals to minus 1 over e ln e, which we can write as 1 over e ln 1 over e. Okay, so which we can write as e to the power ln 1 over e into ln 1 over e. Now it is in the required form. So y is equals to minus e w of ln 1 over e to the power ln 1 over e. So what we get, something e to the power something, from there we get something again minus e, so we get ln 1 over e. Okay, which is equals to minus 1, so y equals to e. So the maximum value of y which we can get into this equation, x raised to the power x raised to the power x to so on, is e. Okay, from this we get x equals to e to the power 1 by e. We cannot substitute greater than e into this equation, otherwise we are not going to get any x value. Okay, so there is not any paradox. That's all. Thank you.